Right, we'll be going through assignment J1, which is about introduction to organic chem. So can you please take out your assignment J1? I'll be going through every question. Okay, let's start off with the MCQ question. So the first part is asking us which of the following pairs are members of the same homologous series. So for same homologous series, they have the same functional group and they usually differ by a CH2 unit. So with that, you can see this is an aldehyde, whereas this is an alcohol. Okay. The second one, you can see that both of them are alcohol and they are only different by this CH2 unit. So therefore, B is likely to be the answer, but we will continue to look at the other options. So this C is a ketone, and this is a carboxylic acid, and D is a ketone, and this is an aldehyde. So therefore, the answer for the first one will be B. Okay, will be B over here. Now, next, which statement is correct about a Lewis acid? So a Lewis acid is seen in a dative bond as an electron pair donor. So being an electron pair donor, it is actually electron rich and therefore is attracted to the opposite charge, which is the nucleus or the positively charged nucleus. So it acts as a nucleophile and it has an electron pair donor. So answer is A. Okay. Now next, looking at the structure, we're supposed to identify amide. Amide will have this structure C double bond O single bond N. Okay, and therefore, if you look at the structure, you will find that the amide is likely to be B, where you have a CH3, CONH2. Now, what is A? A is a COR, so it's ester. And C is RNH2, is amine. And D is amino acid, because it has the amino group as well as the acid group. So if we draw D, it looks like this. C, H, 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 COOH, and H2. So it's amino acid. All right, okay, next. Question 4. What is the IUPAC name of the ester that is formed? So we name the alcohol part first, then the acid part. So the alcohol part has 1 carbon, acid part has 3 carbon, so it will be a methyl propanoate. Answer is D. Okay, next, which is a propyl propanoate. So we need to cut first at the COO. So if we cut at the COO, it will look something like this. Okay, and this is a OCO, so most probably if we cut, it may be like this. Okay, and this one is a ketone. We don't see COO, we see CO, so it's a ketone. And this one, we only see an O, so this is an ether. So out of this two, let's count the carbon. 1, 2, 3. 1, 2, 3. So propyl propanoate. How about B? 1, 2, 3, 4. 1, 2. Ethyl butanoate. Okay? So B is ethyl butanoate. A is propyl propanoate. So answer is A. What is the IUPAC name of this? So if you draw out, you will see that it is an ester. So an ester, we will usually have to cut it up and name the alcohol part first, which has 3 carbon. So this is a propyl. And this is a 1 carbon methyl. Right, so the answer is propyl methanoate, D. Okay, next, there are 3 isomers are formed. So the main difference between the isomers will be increased branching. Okay, we are seeing increased extent of branching, and increased branching actually decreases London dispersion force. So in terms of highest boiling point will be number 1, wedged straight chain. Okay, and the lowest boiling point will be the most highly branched structure. So the most highly branched will have the weakest London dispersion force? So the answer is C. Okay, question 8. Structural isomers. In order to be isomers, they must have the same molecular formula. So sometimes you can do a quick check for molecular formula. So this is a total of 5 carbon. Okay, this is a total of also, this is 2, 3, 4, 4 carbon only. And this is 1, 2, 3, 4, 5 carbon. So the one with a 4 carbon will unlikely be a structural isomer because they do not even have the same molecular formula, right? So you have no different molecular formula. So we will have this too. Likely, we just double check the number of H's. So it'll be 5, 6 plus 6, 12, H12, and this is 3, 6, 9, 12, also H12. So same molecular formula for 1 and 3. Okay, they are structural isomers. They have different structures if you draw it out. Okay, so how will the structure be? If it's the first one will be CH3, CH2, 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 CH3. The second one will be CH3, C with a H and a branch CH3, then a CH2, CH3. So there is a branching in the isomer. Number 8 is 1 and 3. Number 9, lowest boiling point, we look at the intermolecular force. So we are seeing hydrogen bond here for alcohol. I'm seeing a hydrogen bond intermolecular force here. And over here, both of them are London dispersion force. So let's sketch out the structure. The first one is CH3, 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 CH3. That is for C. Whereas for D, it's a straight chain. CH3, CH2, 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 CH3. So branching lowers the boiling point. So answer is C. Okay. So the next one is what functional groups can we see? We can see a benzene ring, definitely. Okay. So we can see benzene ring. We are able to see a ketone. So there will be ketone, and there's an amine. So we can see amine, but not amine. So answer is A. Okay, that's for the MCQ. So let's look at the structured question now. So the structured question is one. Okay, so this is the flow chart to make carboxylic acid derivatives. So we start from an alcohol, reacting with an acid to form an ester. So this is an ester, right? This is an alcohol. And then the alcohol can become aldehyde, and aldehyde can become acid. Acid with amine will give you amide. So more or less, we know roughly what's happening. One example of homologous series is alcohol. Describe 2 features. So the 2 features is that they have the same functional group. Or you can say that they have similar chemical properties because of the same functional group, and they have different physical properties because of the increasing CH2 unit. Okay, other possible answers may also include like same general formula. Or differ by a CH2 unit. Okay, so we're supposed to name D, E, F, G. So D, there is an alcohol with a branch. So one of the CH3 is branch here. So alcohol from 1, 2, 3, 4, 5, smallest number given to the OH. So it will be a core of 4-methyl pentyl-1-ol. Okay, so smallest number gives to the alcohol, 4-methyl pentyl-1-ol for D. For E, it is an aldehyde, so it will be 4-methyl pentanal. No need to say it's at number 1 because it's always will be number 1. For F, will also be number 1. So it's called 4-methyl pentanoic acid. Yeah, so F will be called 4-methyl pentanoic acid. Okay, and then the last one will be the G. And if G is an ester, we may have to cut it up. So the alcohol is 4-methyl pentyl, right? So we can see it's called 4-methyl pentyl since it comes from 4-methyl pentanol. So it's called 4-methyl pentyl. And then over here, 2 carbon ethanoate. Okay, 4-methyl pentyl ethanoate. So with this, we have named the IUPAC names. Now, next, we have isomer C5H12, straight chain, 1 branch, 2 branches. Okay, so more extensive branching. So the boiling point for each isomer, so they are saying that it's going to be 10, 28, 36. So the longer straight chain should be the 36. 1 branch will be 28. Heavier branching or more extensive branching will be lowest boiling point. Okay, 10 degrees. So the reason why we assign in this way is because as branching increases, London dispersion force will decrease and the boiling point will decrease. Okay, so we link it back to the extensiveness of the boiling. So we can say that they have the similar molecular structure. A is a straight chain, whereas B and C are branch. Okay, and out of that, the more extensive the branching, then the weaker the London dispersion force and the boiling point decreases. Okay, so with that, if you want to name B is 1, 2, 3, 4. Longest chain is 4 carbon. So we call it 2-methyl butane. If we want to name C, this is the longest chain, 3 carbon. So it's called 2,2-dimethyl propane. Okay, so with that, we finish assignment J1. Okay, I may want to do assignment J2 for only the MCQ part first. So MCQ part of J2, which one has 2 enantiomers? So if you want to see enantiomers, we will have to see chiral carbon. So look for a carbon which has 4 different substituents, which is this here. So this carbon is bonded to a H, bonded to a Br, bonded to a CH3, and bonded to CH2CH2. All right. Why the rest are not chiral carbon? Because here you are bonded to 2 bromine. So you do not have 4 different groups. Here you are bonded to 2 hydrogen. Here you are bonded to both 2 ethyl group, left and right. Okay, so answer is, for this case, you need a chiral carbon is B. Now, next one, we need to find cis trans. So you'll find that in this configuration, both are on the same side, we call it cis. In this configuration, both are on the opposite side, we call it trans, right? And this is the same structure. Z and W is exactly the same. And why? Because of 2 groups which H bonded on the same carbon, there's no cis trans. So with that, the answer is X and Z. Okay, question 3. Which one as a bit optical isomerism? Of course, have to draw, no choice for this. Okay, do a quick sketch. If it's a aldo, so do you see these 2 groups are the same? Right, left and right are the same. So wrong. Methyl propane. This is a CH3 and this is an aldo. CH3, CH3, CH3. So no. Okay, 1,3-diiodopropane. So you can see here, this carbon, none of the carbon has a chiral carbon. And the next one, 2-iodobutane. So you have one CH3, one H, one I, one C2H5. So answer is D. There's a chiral carbon. Okay. Now, next question, which one is optically active? Again, look for 4 different substituents on the carbon. So obviously, it's not this. These are all the same. So you have the same white balls everywhere. This one, there is a chiral carbon. It's a HC2H5, something else, chloro, and CH3. So answer is B, but we will double check the rest. So the rest, no chiral carbon. This carbon has 2 similar H group. So again, no. And the last one, all the 4 groups are the same. So no. Okay. Which statement about stereoisomers are correct? So stereoisomers, you can see they are asking either 1,2-dichloroethane or 1,2-dichloroethene. So we can just draw it out. 1,2-dichloroethene. And then they also ask about 1,2-dichloroethane. So in 1,2-dichloroethane here, we can see there's no optical isomers because there's no chiral carbon. So this will be wrong. Alkene has no optical isomers because it cannot form 4 different substituents. So the best answer for this will be the one which has a double bond and it has cis-trans isomers. C. Okay, question 5. Question 6. Which one can rotate light? Again, look for carbon with 4 different substituents. Train your eyes to see it. So this carbon over here is actually bonded to 2 methyl groups, so no. Okay, the next one, every carbon, you can see there's H2, H2, H2. So no, because every time they have 2 H. This one is H2, then there's a CHCl, so possible. So let's look at this. It's bonded to a H, bonded to a Cl, bonded to a CH3, and bonded to a C2H5. So answer is C. Okay, whereas the third one, 3 of the groups are the same, all methyl group. So no chiral carbon. Okay, which one will rotate a plane polarized light? We look for the Y. So if I look for the Y, I'm seeing the Y here. I'm also seeing this here. This one, although I see the Y, this one I also have a Y here. This one, although I see a Y, I see a Y right here. But this side and this side is exactly the same. So therefore, there's no 4 different substituents. So this one, no chiral carbon. And this one, this is a CH3, this is a CH3. So even if I see a Y over here, it's not chiral. Okay, and then this one, is this chiral? Let's check. Left-hand side is this, right-hand side is this. It's exactly the same group. So no chiral. Okay, this one no chiral because both same group. This one no chiral because left and right of the ring are the same. So with that, question 7 is A. Okay, next one, free radical mechanism. Which of the reaction occurs via free radical? We are looking for alkanes. So let's look for an alkane. This is an alkane. Number 1 is an alkane. Number 2 is an alkene. So you have addition reaction. Number 3 is a halogenoalkane. So nucleophilic sub. Number 4 is also a form of nucleophilic sub where the Cl is substituted by water. Okay, so answer is A. Next, which of the following will be present at the end of the chlorination of methane? I will have chloromethane. I may have dichloro because of multiple substitution. I also get ethane because the termination step 2 methyl radicals combine together. And then that happens, it gives me a longer hydrocarbon form methane. Okay, and you also have HCl in the first propagation step. First propagation step always form HCl. So therefore, everything. Okay, last MCQ question. Which of the following shows the incomplete combustion of methane? If it's incomplete combustion, you should get CO, you should not get CO2, but you get CO and C. So answer will be 2 and 3. Okay, now we'll stop here. We'll not go through the structured first. So we have done 20 MCQ questions and some structured. So now we are stopping at J2 structured question.